Okay, let's continue with actually the next lecture material, information systems medicine. So before it, I more talk about different statistical, mathematical methods which could be used to make decision. Practically, most time all that things work inside specific information system. So they not work separately, but they implemented within specific information system. Except situation when you investigate some kind of new case, when you work more as researcher, definitely in this case you will need directly implement, for example, hypothesis testing method. Even in this case, more specific solution could be helpful. For example, like application like Statistica or R or any other, and maybe you will need to retrieve information from existing information system. For example, if you have patient data collected within particular hospital information system, okay, maybe you will need to establish interaction between R and that hospital information system in order to retrieve patient data for analysis. But right now, I will just try to provide some introduction into different types of information system. In general, how we can, what is this, and how we can classify it, and how we consider different types of information system, and what is available classes of information system related to medicine. Actually, at least two types I have already introduced at lecture 3 when I have spoken about medical images. There I was presented one of a pair of type. But right now, more widely, I will try to talk about what's happened, not working. Somebody shut down attention. If somebody shut down projector with your phone infrared port, no, you bother not me because I see everything. It will be you made something problem for your friends, not for me. Not. If you will continue such activities, I will just ignore it. You make problem not for me, for students. So first question, I will try to present information about definition, classification, and areas of studying under information technologies, and major classification of information systems. So, in short, in very brief and simple way, information system person that records activities, process data information in given organization, including manual process and automated process. So despite its relatively old definition, it's still correct. And you must remember that like there are nothing to write about computer systems. So yes, for sure, information system born far before computers were developed. And it's just, we are talking about principles of information processing. And it could be done even with pen and paper and qualified staff members of particular organization. For sure, in modern time, it's not an effective way, but it's possible. It's still possible in case of emergency or some critical situation. So, as for me, I will interested in computer-based information systems, and it's information technologies component of information system. So again, information system, it's not a computer. It's information technology component of information system. So important to understand these things. And it's field for study of information technology as scientific area. And we must understand that information technology have dual meaning, like academic field, scientific area, or as sum of technologies and particular implementation of it. So information system, we can define as combination of information technologies and people activities that support organization management and decision making. In case if we talk about computer-based information system, in this case, from both definition must be obvious that I made emphasis on people's activities. So when we talk about information system, we can't consider only hardware, software solution. We can't consider only computers and computer software. It's combination how this work together. Computer systems, networks, and staff members. If we have failed at one of the steps, information system fail to work. And what I see practically, most of fails I observe it comes from us, from humans. And here is a problem. And it's even grown, actually. In this case, I combine both things. I combine like staff member mistakes and errors, but as well, I included there another kind of failures, like security breaches, hacks, cracks, and all other similar things. Because they also comes from humans. Intention comes from humans. And it's also a human problem. Okay, so again I summarize previously mentioned things by this chart. If we talk about components of modern computer-based information system, it's interaction of following components. Staff members, who is actors and who perform different activities with all activities with information system. Computer system, which include the hardware, software solution, and cannot be separated. Networks, which allow for us to interact data, so it's impossible to have information system without network right now. And data, which is processed by people with help of particular hardware, software, and network solution. And under data, we can talk about all possible kind of information system. So I don't want to spend a lot of time about the different historical review. So we could spend like even several lectures, just like important points in changes of emphasis. Like beginning of development of practical information system starts at the end of 50s, at the beginning of 1960s years, and has been started with so-called data entry system or transaction processing system. 12 decades, it's evolved into system which could allow for us full automation of different business processes and organizational processes within different organizations, with all kinds of human activities. As a result, we talk about fully automated businesses right now, or even electronic or e-businesses. So here it's accessible right now. And in medicine also it's possible. So, scientific area which is dedicated to study and development of these related activities, it will be information technologies. As academic field, it studies which deal with study, design, development, implementation, support, and management of computer-based information system, particular software application, and computer hardware solution. So there I will talk about academic meanings, academic definition of information technologies. But actually, we must understand that information technology is, in practical meanings, it's practical solution and implementation of how these defined things. So we have two definitions, practical and academic. Here is we consider academic. In same way, information system have academic definition. So it's scientific field for study that address range of strategic, managerial, operational activities involved in gathering, processing, storing, distribution, and usage of information and associated technologies in society and organization. So in this case, again, we must understand information system as practical solution dedicated to perform any activities, but also scientific area which study how to create such system. two meanings, practical and academic. On classes, theoretically, when you will have quizzes, you must provide this definition. Practically, we will deal with some particular solution dedicated to fit data into medical area and special. And we can depict relationship between all this scientific area, like computer science, information science, and information system and application to specific business world. And the business management world, I mean not only like commercial solution, but in this case, even like educational area, even and for sure our clinical areas also fall under this right side under business management world solution. So we have these depicted requirements from a particular business. We can, information technologies could recommend some specific information system solution, which must be based on top of information achievement in the information theory here, and which is implemented through mathematical and engineering and finalized with specific computer hardware development, which could be fueled with software and could finally create specific information system solution. And which will be delivered, so there in yellow we have specific solution like management information system, knowledge management system, decision support system, and so on, and it could be delivered to fit needs of particular business. So here is in yellow we have like final solution, results of implementation of information technology and information system as scientific area. This blue range in center. As of about classification of information system, so I will try to present multiply areas, and especially we will start with hierarchical representation of classes of information system. So at top level, at the basement of pyramid, we have so-called transaction processing system used for automate everyday routine like perform data entry at reception, no matter where is reception is, at clinic or at bank. It's everyday routine, and in both cases we have transaction processing system. Separate or component of integrated system work. Then, if we move into management area, toward top of pyramid, we will have 2 or 3 classes. I assigned 2 or 3. They are brought at 3 classes of management level, but it could be sometimes in different sources represented as 2, like management information system, decision support system, or executive information system. Very often, we can see situations like decision support and executive system could be shown out together as one single stage. It's no problem, it's not a mistake. It's just different viewpoint. So at that level, we must be, when we are closely to top of pyramid, any input activities must be minimized and only decision-making activities must be taken into account and concentrated on this. So managers have not go out to input something. They are looking for review, performance of organization, and looking for best solution and best decision. So actually in this case, physician in hospital also must work more as managers rather than like clerks of data entry. In this case, it's typically normal case when nursing staff must work with transaction processing system, and physician must work at least of a management information system level. So actually, as I assign, within transaction processing system, it's kind of information system or module or component of general information system that collects, store, and modify a tray of transaction organization. Here, most time users, when heard about transaction, imagine immediately money transfer. It's true, but it's not only limited by this point. Under transaction, we must understand event that generate or modify data and that is eventually stored in information system. And main idea of transaction program that its managed data must be left in consistent state. So, like in case of most easy to, it's of course imagine through money transfer. When payment made, the account must be both withdrawn from one side and add to another. And transaction will be completed only when both or even transfer of operation completed successfully. If we face any failure at any stage, no matter what, like not enough money, like break transmission line when data transmitted, error in transmission data, or like recipient account locked or down for any reason or something happened, we must, for a transaction, must be reverted back. So everything must be back to original state. So transaction, it's like moving to consistent state. When we update some data into, for example, physician tried to use phone to update, much more easy situation. Like our teachers try to use mobile ASU version, mobile electronic journal to put marks for students or update marks for students. It's also a transaction process. So marks must be assigned only it will be recorded in the database, not yearly. And if something happens through communication, students must receive, teacher must receive notification that mark does not record it, like nothing recorded, and so on. So example how transaction works also could be shown at this picture. Where is place of transaction? When we provide some input and before it will be completed until to recipient. Something happened again. So as of about other levels of pyramids that I depict earlier, Management Information System or MIS, please don't mix it with medical information system. Same abbreviate. There are MIS and in that place also MIS. Under MIS we can understand management information system, but depending to area we are speaking about, it's also medical information system. Same abbreviate, different meanings. So they provide information that it's need to manage organization efficiently and effectively. So as I told, it's also not necessary to be only computer system. This system comprises components like technology, peoples, and data information. So it could be even, all this task could be completed even without computer, but it will be not very effective in modern time. And also, when we talk about management information system, we must understand that it could be separate as well as component within integrated system in different circumstances, in different particular solution. There may be a raised question about difference between management information system and next level, decision support system or executive information system. So here is, it's like external level. What do we hear? Management information systems there inside. So major key points, decision made by human, by manager itself, from system obtained only available information in forms of reports, charts, or other integrated representation. But final decision they only be done by human, by manager itself. But when we talk about decision support systems, they must include the components which allow to make assumption and provide some recommendation decision and even perform what if analysis so about effectiveness of organization and use different quantitative techniques with electronic learning methods to improve computer system data processing algorithms. No, there I am talking more about expert system, not about clear decision support system, but in fact it's something about this one. So at this point, definition, decision support system or DSS, computer-based information systems that support business organizational decision-making activities. In this case, we have strongly spoken only about computer-based information system. And that's management, operational, and planning levels of organization and help to make decisions, which may improve quality of organization. So again, what is the difference between management and decision support system? Depending to viewpoint and defined task, it could be a lot of it, and a particular chart only presents some possible part of representation. So it could be in what kind of decision provided, what kind of information and frequency of update of this information could be found within this type. Format of data could be even different, and so on. And here is we have in brief, we can. It will be not very big mistake when we talk about management information system provide information, provide summarization and aggregation of data already collected within transaction processing system, and left for manager to provide any decision. And we are talking about definitely strong periods and clearly defined type of data which is already collected, I signed there. With the decision support system, we are not strongly limited. We are talking about multiple, adding extra different data types and format and periodical assessment, and we made emphasis on simulation and modeling rather on aggregation of data. Within executive information system, it's specific advanced case of decision support system or a special type of management information system, and intended to facilitate and support information and decision-making needs for senior executive. And here is we talk about interaction with multiple data source from different measures, which is retrieved from inside organization or different market assessment and so on. It's a very specific case. So all this summarization of different level of activity, like depending to management level, like operational, tactical, and strategic. So we can fit this three sections, like management information, decision support, and executive information system could be placed within this three level of management only pyramid. So there I do not show transaction processing system at this point. Okay, as of about detailed classification of different type of information system, we can consider it there in like 2 groups and 3 classes. So here is will be support of operation support system, management support system, and third, not strongly depicted class, which is related to expert system and expert decision making. So even in addition to conventional transaction processing system, we can separate multiple classes. For example, in case of like manufacturing factories and plants, we are talking about usage of process control system, which is actually a specific class of transaction processing system. And even a process control system could be, in this class, we can include a laboratory information system. It's actually, they are more closely to a process control system rather than transaction processing system, and so on. Same way, management information, decision, executive information system, all that fall under general management support system class. In contrast to it, expert knowledge management strategic information system could form special group which is interact like between actually, because have features from both, from operation support as well as management support. They form this third bottom group. Here it is. I'm talking about this. But such structures could be variety, could be different depending to information source. If you take another textbook, another internet site, probably will have another representation, like this one. So here is we have again, like same classes, operation support management and office automation system, but slightly different in components of these classes. So now if you want to move into application of information system in healthcare and medicine, and more generalized in healthcare, so with the following chart, as you can see, we have actually a lot of possible application. Especially for sure we will concentrate, what is most important, it's create electronic medical health records at this point, and provide different decision making, but we can involve it in education. So we have like a learning management system module dedicated to perform medical education. We are talking about usage of information system in medical education, no problem. Or same way we have if we use like billing and transaction processing system in to offer like paid services in hospital. We talk about e-commerce usage of e-commerce system into healthcare. So finally we have multiply application and multiply usage of different type of information system in medical to fit different medical tasks. Practically, I will just quickly run over several general types like hospital information system, radiology, laboratory, and picture-hearing communication system. Especially last one time I have presented, so maybe I will omit if I doesn't have enough time. But before it's brief several words about general and most common medical information system. Again, when we talk about MIS, in this case medical information system, it's like general representation of different type of information system in medicine. Because then we need to provide more details. What actually we are talking about? Is it hospital or clinical information system, laboratory or picture-hearing communication system? Which one of it we are talking about? About which one particular, or it's clinical decision support system, or it's medical expert system? Which one? So within both SIS or CIS, hospital as well as clinical information system, we are talking about replacement of paper-based information processing and with electronic data processing and with creating electronic medical records. So, but also both systems, it's integrated and designed to manage different aspects like administrative, financial, and clinical aspects of data management in hospitals. So they not only cover medical records management and even the hospital information system, especially dedicated even not for this, so clinical aspects even not on first place. Practically, we want to replace like tower of paper and like maybe tunnels of shelf with folders with something more useful, even one patient knows. And it's actually in Ukraine even worse. This picture is from England. It's not from Ukraine, it's from England. It's from England. So in Ukraine we have much worse situation, clearly. So we want to get something like this one. It would be fine in ideal case, but even in high developed countries, it's still far from being perfectly resolved. In Ukraine, we have a much worse condition because actually we have it in very low stage of implementation of electronic medical records. So finally, our idea is to establish electronic data processing and especially exchange between different facilities. It would be extremely fine, but it's we have large problem with this. So major benefits for sure it's create electronic medical records for clinical case, but also we have much more related to it benefits. For example, efficient statistics, like effective planning and budgeting, even support research and education. It would be fine too easy to retrieve clinical data case from electronic medical records rather than paper. As of about historical review of information systems, they are very like similar to previous I demonstrate for general information system history. It's born relatively at that time at the beginning of 19th century, at the beginning of 1960s of 20th century, and up to end of 20th century, its evolution into adaptable distributed system. But if you ask me why it's ended with end of 20th century, it happens within like last 25 years. Honestly, we like turn back. No, clearly, we not get back into monolithic solution. We like turn, move into spiral way into level above. Modern system, we move now into cloud-based solution when distributed system deployed to cloud and available to customers as services. When no longer need to deploy multiply information system per each hospital department, we no longer need to keep like server storages into hospital directly. What do we need? It's only connection lines and reliable network equipment and simply physician with their communication device. And then subscribe to service, like hospital or medical information system on hospital level. Have you heard what I said? Hope for this. Now at this point would be fine the big difference between CIS and HIS. So what is difference? Why I have determined that we have two, clinical as well as hospital information system. So former or clinical information system concentrate on patient-related, clinical state-related data. So they are responsible for formation, support, maintain electronic patient record itself. Then latter, or HIS, hospital information system, keeps track of administrative issues. So like budgeting, scheduling, and track of staff track and other related questions. Definitely, HIS could support electronic medical records too, but it's not their primary activities. Again, CIS concentrate on patient data, HIS concentrate on hospital data, and its key points. So, as shown below, distinct not clear. It's after that everything depends to vendor who supply for you specific information system. And it's actually a major problem, but it's not easy to select particular information system to your hospital because we have too many different proposals. And they are really different. They have different emphasis for different aim. And you must have clear view for aim of your automation, what you want to achieve. You want to have like extremely reliable storage of patient data. Okay, emphasis into CIS. Or you need to improve hospital efficiency. I'm sorry, HIS will be there, better solution. So, as of about specific tasks which could be implemented through both HIS and CIS, and especially with emphasis to HIS. It's administrative, patient data collection, decision, monitoring, reporting, assessment. Okay, so here is made emphasis on administrative support. So this list fits to hospital information system or SIS. How to turn to SIS? Okay, we need just take administrative support, first point, and move it down into about like 5th position. And bring patient data collection, decision monitoring above. So here is we move from SIS to CIS. Sound easy, but if we have already developed specific software, it cannot be updated and cannot be moved. So if you've made fail of decision, you will need to buy another software. And probably you will, it will cost a lot of money. Practically, this point not clear. And practically, very often we work with integrated hospital information system, which consists of multiply programming components, multiply modules. And you need only, for example, buy or subscribe to specific modules, depending to model of implementation what you have chosen. If you deploy a solution to your own computers, you need broke multiply modules. If you subscribe to online services, okay, you need to choose which modules need to be subscribed to fit your requirements. And here is another representation if we talk about create integrated solution. Or you can, okay, even available even third way, you can select multiply application and, for example, hire software developers who will create API programming interface between these modules to establish information exchange. Actually, these things, it's what is now under implementation in Ukraine, so-called e-HEALth, or governmental integrated hospital medical information system. So they are not provide medical records keeping service. No, they provide central storage for different data types, and developers of vendors of specific medical information system fully responsible to create programming interface to interact with governmental system. That's something wrong. Okay. So, and this slide is just example how specific hospital information system could be composed by multiply different components, multiply data storage, these cylinders, and how it could interact with multiply input data types, which could be represented by different standards and data formats, and could be implemented with inference engine, which prepare different reporting services, help hint services, and other informational services activities. And even we can create multiply external representation, web and clinical, and even interact with external databases. So at this point would be fine to introduce question about data integration. So very actually not easy to understand, but critically important to at least know about these things. As I have multiply times repeated that medical information system could be comprised of multiply components. We can have multiply application and multiply storages, and even you sell this at diagram yearly. So we need to find some way to bring this all together and get some useful at end. So we have 3 layers of integration. First of all, most simple, it's data integration. We have one central storage of our data, And then we have multiply application which access this central storage in order to retrieve or write into data components. Like we have components for nurse, for physician in different hospital department, and one central database within hospital where all data collected. One of possible approach. Another way, presentation integration. Would be fine if the doctor move from one department to another, he have ability to work with that system. If nurse has been moved from one to another department, it will be no need to teach her or his how to work with system. So here is we have presentation integration. When different application looks in same similar manner. Fine example is Microsoft Office Suite. When we have multiply of different application, text processor, spreadsheet application, even database, and we have like very similar user interface, similar icons, menu commands, etc. And what is most important, we can even call one application from inside another. We can get access to one application from inside another. But these things, it must be important to understand, it's actually move us into even another level of integration. So because there we are talking about combination of data integration as well as function integration, this one. When we have function from one application available within another, within central interface. Simple example, it's G Suite, Google Apps for Education or Google Apps in general. They are available through web browser. We have one application, web browser, and we use web pages to access different services like mail, drive, sites, and so on. But here is again, we have presentation integration as well. And even we have data integration in this time, because you register only one time. And for you are accessible different services, email and drive, with very similar interfaces. And even you can put like attachment from your drive into your email. So what I want to talk, real system, real modern system, combine all these three integration together. We have all at a time, data, function, and presentational integration at one time in our modern system. Not only G Suite, Microsoft Office too. But we must be able to distinguish what is different between this type of integration, what is there. Okay, practically how it could look like, so like structure of distributed system, when even branches of out of site and even out of country, how we can establish information exchange, shown there, and how we can manage multiply data storages and multiply data source. Practically, so this, it's actually a representation for system architect, for developer. And the user will see something like this one. So here is we have integrated system, we stay to support and maintain electronic medical records. But here we have a talk about integrated systems. So we have all together patient record, medical images, and some even analytical and statistical tool all together inside integrated system. Okay, second group, second class, laboratory information system. By definition, we talk about class of software which handle, let's say, process store information generated by medical laboratory. Major features, characteristics, interface with instruments. So they must be able to retrieve data directly from laboratory instruments and collect it into a database. And would be fine, second features, it's how network interface with hospitalization system. So ability to exchange by defining data format and standards with HIS and CIS system. Also about features and tasks and patient check-in, order entry, specimen processing, results entry, create reports, it's required. Patient demographic, physician demographic, not necessary and even could be omitted. First 5, it's required. As a note. Not necessary, but would be fine. For sure, if we have like gateway to HIS, we can retrieve this information from HIS. There will no need to be, it will be fine idea. It prevents to manual entry, it's vast time to manual typing. It would be fine to help automate this most difficult and step which could lead to even cost some mistake. It would be fine to have gateway and retrieve information directly from HIS system. About other features and area of usage, it could be a lot of. They are only present just few of it at this slide. About like high configurable as well as clinical aid. Typical workflow could be represented there, but attention, they are shown not clear hospital lab, not clinical laboratory in hospital. There we're talking more about offshore laboratory, like for example, CNL laboratory, which is working in Ukraine, in Ternopil especially. When we collect samples from different patients from different hospitals, organize it into central database, then even maybe we will need to deploy to some analysis point. Maybe its analysis will be done not at this site, somewhere else. And then we have collect results into centralized data storage, even paper backup. Attention, it's not bad idea to have paper report every day to safety condition. And then deploy results for physician or for users itself, for patient itself, with all possible communication channels. But for example, for years I now need to visit repeatedly to CNL laboratory to collect my results of my test. They send me to my email. And would be fine if they will be able to send to my family doctor. But at the moment, not. They can't. I need to bring it to my physician. Just 2 words about laboratory information management system. Computer software used laboratory for management of samples, laboratory users, instrument standards, and other laboratory functions, such as invoicing, plates, and so on and so on. So, difference. Very similar things, LIS and LIMS. So, LIMS targeted environmental research and commercial analysis. For example, pharmaceutical, petrochemical. For commercial and for scientific research. LIS, second type of system, targeted toward clinical market. Provide analysis within clinical laboratory. There. Okay, details I will omit because our features the same, like interface with instruments, high configurability and register multiply data responses. So, okay, I will skip because we're out of time. User interface could look like this one. It's one of dozens version. No worse, no best. One of possible. Okay, 3rd class, radiology information system. It's 4th class actually. Used radiology department to store, manipulate, and distribute patient radiology data. So features very similar to such for laboratory information system. Patient registration, scanning, entry, reporting. Also RIS, very similar to PACS, picture communication system. And even also must deal with imaging device, would be fine. But also must be tightly connected to hospital information system. So their structures, again, they are assigned that we have strong interface with imaging devices. Okay, digital versus radiology, as you can see, it's like depicted that we have packs inside of RIS. So here is about relationship of RIS and packs. This vendor talks that they have packs inside the RIS. Here is the representation. About so question around picture human communication system, which is actually a computer network dedicated to storage, retrieval, distribution, presentation, and image. Actually, I provide this information at third lecture. I think it's no reason to repeat again. Just I sign important notice. Last part. Significant critical characteristics of PACS, its ability to support DCOM, digital imaging communication medicine. If system not support DCOM data format, it's not a PACS. And actually it's not RIS, because RIS also must support DCOM. Also important features around this. So how PACS could look like? I show this chart earlier. Aim of usage of PACS. I also depicted features of DCOM. Actually, I have provided third lecture. As here shown again, must have interface with HIS, RIS as well, if you have separate, and place interaction of, so there at this slide you can identify a relationship between hospital information system, radiology information system, and PACS as well. General order correct of all kind of medical information, including visual representation and establish data exchange between different kind of medical information system. So all the three components could be separated system independent, which is establish relationship by network and application programming interface, or in other hand, all this three system, it could be components of general hospital integrated information system. Okay, I think that's all that we need, that I can provide for today. Thank you for your attention.